What is going on? Can I not write there? Okay, I guess I can't write up there, so I guess we'll write down here. 5.2. Trig functions. All right, so our first problems, they give us a coordinate, like an XY coordinate. We have to graph it on a coordinate plane, like that point, and then we're going to make a triangle out of it and solve for all 6 trig functions of that angle. So, 12, we've got -12 and -5 are the points, or like -12, -5. It's XY coordinate. So I set up a little mini coordinate plane here. And I'm going to basically just roughly put this point where it would be. It doesn't need to be like drawn to scale or anything. But that point would be somewhere down in here. And I'm going to make a triangle with it. Now, when you do these problems, the triangle always, always, always has to have a side on the x-axis, okay, and not the y. So that's going to be the biggest issue with these is people draw it the wrong way and thus get the problem wrong. So it's always, always, always going to touch the x, never the y. So -12 is our x value, so that's going to go here. -5 is our y, so that's going to go here. And we need to solve for the third side so that then we can find all 6 trig functions of that angle that I just arced off there. How would I find the third side of this right triangle?
Geometry stuff, right? It's like
A squared plus B squared equals C squared, the Pythagorean theorem. So -12 squared plus -5 squared. I don't know why I just put parentheses around the whole thing. Equals C squared. So this is the square root of 144 plus 25, which is the square root of 169. Does anybody know what that square root is? It's a perfect one. 13. So C is 13. So this side length is 13. The hypotenuse value always has to be positive regardless of what x and y are. Like that long side here always has to be positive. So now I'm going to set up all 6 trig functions. I set them up this way on purpose because this is the function and its opposite. Okay, so the opposite of sine is cosecant, the opposite of cosine is secant, and the opposite of tangent is cotangent. So when I find these 3, all I have to do is flip them upside down, and I have the other 3. So sine is opposite over hypotenuse, so this is going to be -5 over 13. Cosine is adjacent over hypotenuse, so -12 over 13. And tangent is opposite over adjacent, so it's -5 over -12, which is going to be +5 over +12. The negatives are going to cancel. So now, when I go to the other side, all I have to do is flip them over. So cosecant is going to be 13 over -5. And just because a lot of people have this question, the negative can go on the top, the bottom, or in front. It doesn't matter. It's going to make the whole thing negative regardless of where you put it. So if you put it on top instead, like no points are going off or anything. It's the same answer. Secant is -13 over 12. Cotangent is 12 over 5. You solved your first triangle. First of many. Tristan, have you done this before? Okay. Because you've had trig, right? Okay. All right. Let's do another one in a different quadrant. 16. 15, -8. So where is this point going to be? Like, you can tell me bottom or top, right or left.
Bottom right.
Bottom right. X is positive, huh?
Because it's like 1, 2, 3, 4. Like,
oh. I was like, what? I was like, what are you talking about? Thought you were trying to tell me the other side is going to be 4, and I was like, that's not possible. Yeah, so bottom right, X is positive, Y is negative, so it'll be down here. And again, I draw it touching the X axis, not the Y. Doesn't look like a right triangle, but it is. So my X value is 15. Y is -8. So I need to find the other side. So I'm going to do c squared equals 15 squared plus -8 squared. Oh goodness, this one I don't just know off the top of my head. Where's my calculator? Well, I think 15 squared is 225, but check. Yes. Okay, so square root of 225 plus 64. The square root of 289. Is that a perfect square? It is. It's 17. So this side length here is 17. So now, sine of theta would be what? The -8 part is right, but it's not 15. It's over the hypotenuse.
Oh, 17.
Wait,
17.
what? How do we know where the
The angle is always going to be at the origin. Like from the x-axis to whatever that, yeah.
Isn't there a way to memorize like what you do for each one?
Like for how to find these? Is that what you're
Like,
asking?
Which one is opposite and hypotenuse?
Oh yeah, SOHCAHTOA. Is that what you're talking about?
Yeah.
Okay, yeah.
That's what we did last year.
Yeah, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Have y'all seen that before? Geometry.
Geometry? I did it.
Were you here for geometry?
I did it, but I did it on
But I mean, like, you weren't here. You didn't have Miss
Yeah.
Marshall. Oh, okay.
I was on the computer, and I just, never mind. It was homeschooled. I had my methods.
We all know. I know how homeschool works.
Yeah. It's the easiest thing I've ever done.
Okay, well, yes, sine is opposite over hypotenuse, so cosine is adjacent over hypotenuse, so what is that value going to be?
Oh, 15 over 17.
15 over 17. Tangent.
8 over 17. 8 over 15.
-8 over 15.
Oh, yeah.
Yeah, opposite over adjacent. So then I can do cosecant, secant, and cotangent. So what would cosecant be?
17 over 8 or negative, whatever, negative 17.
Yep, Negative 17 over 8. Secant.
Negative 17 over 15.
It's positive.
Oh, I mean positive.
17 over 15. Cotangent.
Negative 15 over 8.
Yep, negative 15 over 8. Let's see.
The only reason I remember that is
I'm trying to see.
in 8th grade the teacher said like our teacher got up on a chair and sounded like Indian policeman. So
What?
So good tell.
in 8th grade my teacher said like the teacher got fired because they did that. Or something. Not at that school, it was like on the news or something.
Oh, I was like, what?
And you're fired.
Because it was like racist or something. That's the only reason I remember that.
I'll remember it now.
Yeah, I just remember SOHCAHTOA, but there are a bunch of like acronyms for how to remember that. My father-in-law has something about a horse, but I could not tell you what it is. I don't know. I don't remember what the saying is, but anyways, there's some saying. There's a bunch. You Google if you're like having trouble remembering SOHCAHTOA. There's like phrases you can remember, but I feel like it's just easier to remember this than whatever those long phrases are. I don't know. Maybe that's just me, but okay. I was trying to get one. Nope, I just did that one. Okay, sometimes I'm just going to tell you when you do these values, they're going to come out to be a square root. Like you can't, like they're not like a perfect square. None of these that I can see have that occurring in them. Like, I just checked, like, several of them, like, oh, I'm going to do one, and then they all were perfect squares. So I'm thinking that's going to come in a later section. But if for some reason you end up having one that has square roots in it, like, just ask me about it so I can go over it. But normally I just tell you to leave the square root. We'll, like, reduce the square root down as much as possible. Like, if it was a square root of 8, we would rewrite it as 2 root 2. But I don't see any that are doing that right now, so just don't worry about that until we get there. Okay. All right, now is where we're going to need our unit circle briefly. So I'm going to, like, scroll back up to mine, but it's probably easier if you have yours there. Okay. Find the indicated function value if it's undefined, say so. So 52 with a sine of 90 degrees. So I'm going to my unit circle and I'm finding 90 degrees. So that's up here. And I'm finding the y value. So that's going to be 1. So the sine of 90 degrees is 1.
Exactly.
We'll do more, don't worry. Getting a bunch of looks like I have 5 heads, so. So remember, sine is the y values, cosine are x values. All right, 54. Cotangent of 90 degrees. Okay, now cotangent isn't given to us on our unit circle. However, we know that tangent
0
at 90 is undefined. But tangent is in general y over x. I think that was in your notes, but I'm not sure. Yes, it is. But cotangent is the opposite, so it's going to be x over y. So cotangent at 90, I'm going to go look at the x and y value and then write it over top of each other. So still at 90, x is 0, y is 1, so it's going to be 0 divided by 1. And 0 divided by 1 is what?
0.
0. Let's see. 56. Cosecant of 270 degrees. So cosecant is related to what other trig function? It's the inverse of what other trig function?
0,
Well,
it's-
cosecant goes with what? What other trig function? Like, what's its buddy pair?
oh,
Up here. What's its buddy pair?
yeah.
Cosecant went with sine.
Oh.
Cosecant went with sine. So I'm going to think about this as whatever the sine value is here. So this is going to be 1 over the sine of 270. Okay, so 270 degrees is down here. So the sine value of 270 degrees would be what?
Undefined.
That's tangent. Sine is y,
So -1.
negative 1. So this would be 1 over negative 1, also known as negative 1. So negative 1 would be the answer to this cosecant of 270. $58. Cosine of negative 90 degrees. So normally positive 90, okay, we go up, it's counterclockwise, okay, and so 90 degrees would go from here, from here to here, okay, but negative 90, we go the opposite direction, so negative 90 is going to be down here. Okay, so this is equivalent to, we can think about it as the cosine of 270 degrees. Those are equivalent. So what is the cosine value down here at 270 or negative 90 degrees? Cosine goes with what letter? X. So what's the x value of this coordinate? 0. So this is equal to 0.
Simple.
All right, 60. Tangent of 450 degrees. Now, is 450 degrees explicitly written on your unit circle?
Nope.
No, because how many degrees are in a circle?
360.
360. So that means I'm going to go around one full time and another partial time.
90.
Okay, yep. So the difference, or you can use the coterminal angles that we've done. I think we did that yesterday. I don't know. All my trig classes run together. So if I ever say something and you're like, I don't think we covered that, just tell me, because I'm teaching trig in 3 different classes at the moment. And so sometimes they run together in what class I've taught something in. So if you're ever like super confused, just be like, I don't think we've taught that yet. And then I'll backtrack. So we go around.
So just be at the 90.
So 1 full time is 360. 90 more degrees would put us at 450. So yes, so it's up here. And we're looking at tangent. So what is the tangent at 90? It's what's written in the outermost part of the circle.
0.
And the 0.
It's these values out here.
Oh.
Stuff outside the ordered
Undefined.
pairs. Undefined. So this is, I'll write it this way, this is equivalent to the tangent of 90 degrees. And then it is undefined. I'm going to stop there and give you problems, and then we'll do some more with the section tomorrow, but that way we're kind of breaking it up, because the next stuff needs the stuff that we just did, so that way we can make sure you have the like basics before we go into the harder stuff of the section. So based on what you have so far,
I feel so bad for Josh. Josh really
yeah, I think he's going to need to come see me. Let's see, 13. Come on. 17. And then 51 through 59 odd.
What page is that?
518 and 519.